How galaxies form. Theories, variance, and growth. Our best current theory about how galaxies form involves gravity, dark matter, and mergers. The universe contains billions of galaxies, of which our own Milky Way is just one. Often thought of as vast agglomerations of stars, which is how they look in photographs, galaxies actually contain other types of material as well, such as gas, dust, and dark matter. Astronomers know that galaxies began to form soon after the Big Bang, but they don't yet fully understand the process by which they ended up as we see them today. Here are some of the most promising theories of how galaxies form, how and why they merge, as well as the different varieties of galaxies that have been observed. As the universe expanded in size following the Big Bang, all the matter in it was spread out more and more thinly. At the same time, there was a competing effect, the force of gravity, that was pulling this generally diffuse matter into denser clumps. Some of the clumps were just transient affairs that eventually dissipated, but in other cases, the clump's gravity was strong enough to pull in more matter and allow it to grow. As the mass of the clump increased, so did its gravitational pull, causing it to collapse down to a smaller size and higher density. In this way, the first protogalaxies were able to form within the first few 100,000 years of the universe's existence, according to NASA's Goddard Space Flight Center. That much is pretty much agreed by all astronomers. What is less certain is how those first protogalaxies relate to the mature galaxies we see today. Essentially, there are two competing theories, called top-down and bottom-up. The top-down theory, dating from 1962, came first. According to this, the first clumps to collapse took the form of giant gas clouds which were comparable in total mass to present-day galaxies. As the gas collapsed and its density increased, some stars formed very early on, before the gas had stabilized into a rotating disk. These early stars formed the elliptical or bulge-like component of a galaxy, while later stars formed inside the much thinner disk component. The bottom-up theory, also known as the hierarchical clustering model, is more recent and generally considered a better match with current observational evidence. It introduces two new factors that didn't play a major role in the top-down model: dark matter and galactic mergers. We know that dark matter must exist in galaxies because of its effect on their rotation rates, and it seems likely that it played a key part in the original formation of galaxies. But the bottom-up theory, unlike the top-down theory, doesn't assume that the original protogalaxies must have been the same size as present-day ones. Instead, it takes the view that they were much smaller, and it was only later on that they grew to their present size through repeated mergers. Astronomers are pretty confident that mergers played some kind of role in shaping the galaxies we see today. One reason is that powerful telescopes like Hubble have revealed numerous examples of galactic mergers still occurring today. On top of that, the most distant galaxies, which, due to the finite speed at which light travels, are seen as they were billions of years ago, look distinctly smaller and less well-structured than nearby ones, according to NASA's JWST webpage. This seems a clear indication that galaxies must have evolved in the time between their original formation and today. Elliptical. Around a third of galaxies have very little gas or dust and no regions of active star formation. The largest of these, the giant ellipticals, can be up to 300,000 light-years across, while dwarf ellipticals measure only a few thousand light-years. Spiral. These are the most distinctive galaxies, consisting of a thin disk of gas, dust, and stars which displays an often spectacular-looking spiral pattern. Most spiral galaxies also have a small bulge at the center resembling an elliptical galaxy, and possibly a central bar. Irregular. This is the everything else category, neither a smooth, featureless ellipse nor a regular, symmetrical spiral. Irregular-looking galaxies become much more common at larger distances, in other words, earlier in the life of the universe. It's likely that, given time, they will merge into spirals or ellipticals. What is a spiral galaxy? Spiral galaxies are twisted collections of stars and gas that often have beautiful shapes and are made up of hot young stars. Most of the galaxies that scientists have discovered so far are spiral galaxies, as opposed to the other two main categories of galaxy shapes, elliptical and irregular. The Milky Way, the galaxy that includes Earth and our solar system, is an example of a spiral galaxy. Spiral galaxies make up roughly 72% of the galaxies that scientists have observed, according to a 2010 Hubble Space Telescope survey. Most spiral galaxies contain a central bulge surrounded by a flat, rotating disk of stars. The bulge in the center is made up of older, dimmer stars and is thought to contain a supermassive black hole. Approximately two-thirds of spiral galaxies also contain a bar structure through their center, as does the Milky Way. The disk of stars orbiting the bulge separates into arms that circle the galaxy. These spiral arms contain a wealth of gas and dust and younger stars that shine brightly before their quick demise. How the spiral arms form continues to puzzle scientists. One theory suggests the galaxy arms could be the result of density waves traveling through the outer disk. Encounters between galaxies could cause such waves as the mass of the smaller galaxy could affect the structure of the larger galaxy as the two combine. Spiral galaxies are thought to evolve into elliptical galaxies as the spirals get older, but it's unclear how common elliptical galaxies are as they're made up of older, dimmer stars and are more challenging to spot. One of the largest known spiral galaxies is NGC 6872, which is 522,000 light-years across from the tips of its outstretched spiral arms. That's about 5 times the size of the Milky Way. In 2017, astronomers discovered an 11-billion-year-old ancient spiral galaxy called A1689b11. Its discovery will help scientists understand how galaxies transition from highly chaotic, turbulent disks to more organized and thinner disks, like that of the Milky Way. What are elliptical galaxies? Elliptical galaxies are the most abundant type of galaxies found in the universe, but because of their age and dim qualities, they're frequently outshone by younger, brighter collections of stars. Elliptical galaxies lack the swirling arms of their more well-known siblings, spiral galaxies. Instead, they bear the rounded shape of an ellipse, a stretched-out circle. One of the most famous elliptical galaxies is Cygnus A, which is located roughly 600 million light-years from Earth and is an extremely bright radio source. Cygnus A is not only well known to astronomers, but has a place in science fiction. It was featured in the 1985 novel Contact, a Carl Sagan story that later inspired a Hollywood movie of the same name. In 1926, Edwin Hubble devised a system to classify galaxies. Known as the Hubble sequence, or the Hubble tuning fork, it organizes galaxies based on their shape. Under this organization, elliptical galaxies are classified by how stretched out they are. Galaxies classified as E0 appear to be almost perfect circles. Remember, a circle is an ellipse, while those listed as E7 seem much longer than they are wide. A galaxy's appearance is related to how it lies on the sky when viewed from Earth. A galaxy having the E7 shape but seen head-on would appear as an E0, for instance, because observers would not see its stretched shape, which lies behind it. Elliptical galaxies have a broader range in size than other types of galaxies. The smallest are dwarf elliptical galaxies, which can be less than 10% of the size of the Milky Way. But ellipticals can also stretch to more than 1 million light-years across and contain more than 10 trillion stars. M87, identified as one of the largest galaxies in the universe, is classified as an E0 elliptical galaxy. Astronomers have identified more spiral galaxies than ellipticals, but that's simply because the spirals are easier to spot. While spiral galaxies are bright, elliptical galaxies are dim. Spiral galaxies are hotbeds of star formation, but elliptical galaxies aren't nearly as prolific because they contain less gas and dust, which means fewer new and brighter stars are born. The existing stars inside an elliptical galaxy tend to be older, giving off more red light than younger stars. So, why do astronomers think elliptical galaxies dominate the sky? Because when specific regions of the sky are studied in depth, more elliptical galaxies appear. Astronomers think such counts are consistent throughout the universe. Because elliptical galaxies contain older stars and less gas, scientists think that they are nearing the end of the evolutionary line for galaxies. The universe is a violent place, and collisions between galaxies are frequent. Indeed, the Milky Way is due to crash into the Andromeda Galaxy in a few billion years. When two spirals collide, they lose their familiar shape, morphing into the less structured elliptical galaxies. A supermassive black hole is thought to lie at the center of these ancient galaxies. These gluttonous giants consume gas and dust and may play a role in the slower growth of elliptical galaxies. Born from collision, elliptical galaxies are more commonly found around clusters and groups of galaxies. They are less frequently spotted in the early universe, which supports the idea that they evolved from the collisions that came later in the life of a galaxy. Research in just the past few years has revealed quite a bit about the evolution of elliptical galaxies. A 2014 study showed that supermassive black holes might be stopping star formation in elliptical galaxies, which would help explain why there are so few new stars in ellipticals. Previously, astronomers thought ellipticals lacked the cold gas necessary for star formation, but the new study showed that there is actually a lot of cold gas in ellipticals. It's just blasted away by supermassive black holes in the region. In 2015, researchers discovered that some compact ellipticals might lose most of their mass through galaxy interactions, which has large implications for what happens when galaxies merge and collide. Galaxy mergers with ellipticals could even produce weird hybrids, such as the Sombrero Galaxy. A 2012 examination by NASA's Spitzer Space Telescope found that Sombrero is made up of one galaxy inside of another. The study reclassified Sombrero to an elliptical galaxy with a flat disk inside of it. Such examinations sometimes also reclassify elliptical galaxies into other types, such as with UGC 1382 in 2016. Scientists determined that the galaxy was not an elliptical, but a sort of strange combination of cosmic pieces that came about through various mergers. Scientists are now interested in how many other similar galaxies reside in our universe. Join our The Curiosity Dude channel to keep talking space on the latest missions, night sky, and more. And if you have a news tip, correction, or comment, let us know. Please don't forget to subscribe to our channel, like this video, and share video with your friends.